Hello everybody, welcome to fourth interview of DataChannel. Today I have with me Mr. Martin Catherall, all from Melbourne. We are shooting from his wonderful house in Melbourne. I am very happy to have a three-time MVP and one of the community leads of Australia. So, how are you, Martin?
I'm pretty good, Raj. Great to see you here in Melbourne.
Great, that's great. So, all good. Shall we get started with today's interview?
Yeah, sure. Let's start talking about in-memory OLTP.
Yeah, that's great. That's great. Wonderful to know. So in memory, just as our viewers would like to know, can you just give us an overview of what this in-memory feature is?
Yeah, well, it's not specific to a Microsoft or Oracle or any vendor in particular. In fact, a lot of vendors have got their own specific implementation of it. But we're going to talk about the Microsoft implementation.
Okay.
So basically, to sum up, it's a new lock, latch-free, presents a new concurrency model. Although it's in memory, it shares some similarities with the traditional way we think about SQL Server.
Okay.
It's about more than data being in memory.
Okay.
It's about a new model, so to speak, which I guess we'll talk about more as we progress this.
Okay, fine. Interesting. When was this feature released actually? When did this come actually into picture, and is it really different from what we had in the earlier days?
Yes, it is. It is very different. The end result is pretty much the same. We've still got the ACID properties of data and all that. But I believe Microsoft would have started work on this several years ago. I do remember hearing about it at the past summit, I don't know, maybe 3 or 4 years ago. And then they announced Hackathon, as it was the code name.
Okay.
And then in 2014,
it
was released.
Okay.
And I guess similar to Column Store,
Okay.
which was released over time, got gradually better.
Okay.
In memory will likely do the same, because with the subsequent release of 2016,
Okay.
it's developed some new features and it's very interesting technology.
Okay. How different do you think, when we say in memory, how different do you think it's from something like a pin table or something which was there earlier?
Yeah, it's interesting that you bring up pin table. That was probably maybe a little bit before my time. But as I understand it, pin table was a way of basically saying that the whole table would stay in memory in the buffer pool.
Okay.
So your traditional on-disk table, because people are now talking about on-disk tables versus in-memory tables.
Okay.
So you'd run a DBCC command against your disk-based table, and that would basically drag all the data pages from disk into the buffer pool, where it would stay in the buffer pool for quick access during OLTP. Of course, being in the buffer pool, it was still susceptible to locking and latching.
Absolutely.
And all that sort of thing. But the in-memory part now is sits in memory, sits outside the conventional buffer pool, and it's not lock or latch free at all. And we don't need to do anything particular to make it stay in memory, other than actually have that amount of free memory plus some more on top. So it is totally different.
Wonderful. So in memory, if I understand correctly, the data not just resides in memory, but it's also lock and latch free, right?
That is correct.
That's very interesting. What kind of applications do you think would gain significantly via this technology, in memory technology?
Well, I think as the name suggests, it's more directed at OLTP rather than the likes of data warehouses and that, but obviously you can still use it for that. Very high concurrency workloads and that sort of application where you've got a lot of users, a lot of transactions going on. You want to avoid the lock-in and latching that goes along with traditional SQL Server.
Interesting. When people say in memory, there is a strong misconception, or we can call it a fear of sorts. The data, does it get lost? So does that happen?
Well, that is interesting because obviously memory, generally speaking, is transient.
Okay.
So anything that's in memory,
Okay.
obviously if the computer's turned off or whatever, there's a strong potential that is going to be lost.
Okay.
So Microsoft have basically got two models for in memory. You can either have the have the data purely in memory,
Okay.
sitting in your table in memory, and that's what we call schema only.
Okay.
So in both models, the actual table, the metadata for the table, that's persisted. That's going to be persisted all the time.
Okay.
But with schema only, the data that is in the table is basically not persisted.
Okay.
So it doesn't go back to disk.
Okay.
So if the computer is, say, switched off, or if the memory is backed up and restored, then the data will be completely lost.
Okay.
I guess that sort of scenario is applicable for things like session state,
Okay.
or maybe as a replacement for traditional temporary
Templates.
tables.
Okay.
Yeah, that's an interesting use for it.
Okay.
But so long as the DB8 is aware of that, obviously as soon as you say to the DB8 there's a potential to lose data, it rings alarm bells straight away.
Okay. So as long as we say it's persisted, so we expect it is governed by the standard ACID properties.
Yes. So one model is schema only, and the data's just in memory, could be lost.
Okay.
However, we can also have schema and data. And that's where the data, as well as sitting in memory, if you make any changes to it, it is then persisted to disk. It's persisted to disk in a very different way than the traditional mechanism of going to the buffer pool and then going to disk. That's basically streamed to a set of files we call checkpoint file pairs.
Okay. I have specific questions for that.
Right.
Yeah, you're going at a real fast pace.
Okay.
Okay, that's great. Good to know. So as you got started, before we get to the files part, just to make it clear for our viewers, so this in-memory thing, at what are the levels are we setting it? Are we setting it at the table level, or are we setting it at the database level? Can you just brief how people can configure in memory?
Oh yeah, of course. Yeah, so to make a database in memory, because we actually turn it on at the database level rather than the server level. Okay. So to make your database capable of being in memory, you basically need to create an in-memory file group, which is it's different than your traditional file group. It's basically just a folder on disk, a container, very similar to a file stream container. So you run the statement, create your file group, your in-memory container, and at that point you are totally ready to do either schema only or schema and data.
So we can pick the tables that we want to reside in memory, right?
Yeah, you definitely can. In a typical database, you'll probably have a mixture of in-memory tables with traditional on-disk tables.
So now let's come to what you were actually trying to explain. How does the data actually get stored? The in-memory data, how does it get stored on the disk?
Interesting, Raj, because the file container that I just spoke about, inside that directory, inside another subdirectory, you'll see a whole load of files named with GUIDs. Looks slightly weird when you first see them, but they actually contain the in-memory data that's streamed to disk. And they're known as checkpoint file pairs. And as the data is changed in memory, it's streamed to those file pairs. When the database is offline or the server is switched off, all the data is fully persisted to those files. And then when the server is switched back on or the database is online, the data is read into memory.
So are these just to understand, are these files we are talking about, checkpoint files, is the data and the delta files, what are the actual purpose of them? Do they have any difference, like in terms of the use or something, delta file and data file?
Yeah, they're in sets.
Okay.
As I understand it, one set holds the data, and
Okay.
another set will hold the delta
Okay.
to work it out. Because interestingly enough, lots of the data in a memory table, well, all of the data, it's immutable.
Okay.
So as a record goes in, it sits in the database, and then as it's changed,
Okay.
that actually record isn't actually changed.
Okay.
A new record comes in
Okay.
to replace the existing one, and then the existing one becomes the old one,
Okay.
and that's kind of garbage collected.
Okay. Interesting you say that. So it means the changes are actually inserted as new rows, right? So
That's correct.
So does that make the overall process a lot more efficient, because SQL Server need not go and make any changes directly that on the middle of the file? Most of it is up and writes of sorts, or writes getting streamed completely. Does it?
Yeah, that's right. So I mean, that's one of the reasons SQL Server doesn't actually have to lock the
Okay.
record.
Okay.
The isolation levels and that take care of that. So the new record comes in
Okay.
when the transaction's complete.
Okay.
Inside the metadata,
Okay.
a timestamp's updated,
Okay.
and then this record becomes the latest record.
Okay.
The old record is marked as basically an old record,
Okay.
and then a process runs behind the scenes
Okay.
that garbage collects the old records.
Okay.
I guess you could draw an analogy with the ghost process that happens
Okay.
with on disk.
Okay.
I mean, it's not exactly the same,
Okay.
but it's you definitely draw an analogy between that process and the garbage collection process.
Okay, that's great to know. So, what's the maximum amount of memory that in-memory can support? Like,
Yeah, well, that's changed a lot, like in recent versions of Windows operating system. I mean, one of the things I find interesting, I'll answer your question in a minute. Traditionally, we've seen servers with maybe large amounts of disk space, maybe a couple of terabytes of disk space,
okay.
and 128 gigabytes of RAM, or even 512 gigabytes of RAM. So it's kind of disproportional, the amount of disk space versus the amount of memory.
Okay.
However, with not SQL Server, with Windows Server 2016, I believe it can support up to 12 terabytes of memory.
Okay.
So that changes the game quite a lot.
Okay.
We're not going to see that massive disparity between the amount of memory we've got and the amount of disk we've got.
Okay.
So Microsoft generally says, as a rule of thumb, if you're going to put a table or a database in memory, set of tables, maybe have around twice the amount of memory
Okay.
to the table size.
Okay.
So basically, with that amount of memory in your servers, it's up to you really.
Any limit? So the OS maximum is what we can scale up to, or meaning, let's say the OS supports 12 TB, can we scale up to that, or?
I wouldn't scale up to 12
Okay.
terabytes. Like I say, Microsoft recommends maybe twice as much memory
Okay.
to the size of your tables.
Okay. Fine. Fine.
So that's obviously
The recommendation also.
yeah, that's obviously 6 terabytes, which is massive.
Okay.
The only testing I've personally seen is around the 5 terabyte mark.
Okay. Okay. Fine.
Obviously, many people have much less
Okay.
than that.
Okay.
But I think we'll get to the stage where maybe a terabyte or two of collective in-memory tables
Okay.
might be common.
Okay.
It's not the case at the moment, I don't think, but things will
Okay.
change over the years.
That's good to know. Okay. So what happens, just curious, let's say we run out of memory. So what happens in that case? Like, I have, let's say 1 TB of RAM or something, my table has got close to it, or it has run out of it, then what happens then?
Well, I think if you are unlucky enough to run out of memory, because you likely should be monitoring that.
Okay.
You'll probably start seeing a lot of error messages
Okay.
floating around various places.
Okay.
And if you are exceptionally unlucky, you'll probably run into some serious trouble with your
Okay.
database.
So,
So it's best to kind of monitor that
Okay.
sort of
Okay.
that sort of situation.
Okay. How do I? Is there any way I can track how much of in-memory tables I'm using?
Yeah, there's a lot of what you say, telemetry
Okay.
and monitoring tools that
Okay.
we've got. Microsoft's made a whole heap of DMVs available to us,
Okay.
so we can obviously check in there,
Okay.
either manually or with jobs or whatever. There's a whole heap of extended events.
Okay. Okay.
And interestingly enough, they've all got the XTP prefix,
Okay.
and
Okay.
both the DMVs
Okay.
and the extended events.
Okay.
That's extreme transaction processing.
Okay. Okay.
And as well as that, there is quite a few new performance counters for
Okay.
in-memory. So monitoring your metrics through all those tools is an excellent start.
That's great. That's great. So that's great. So combined with these, one should be able to ensure that they don't get into so much of trouble while using in-memory tables.
Oh yeah, definitely. Obviously, people will mix and match the metrics that they want to monitor
Absolutely.
when they want to be alerted and that
Okay.
sort of thing.
Okay.
Um,
Another, besides the tables, if I understand, that is another thing called natively compiled stored procedures. What are these?
Yeah, natively compiled objects.
Okay.
Interesting. Obviously, stored procedures are probably the most popular
Okay.
of natively compiled objects. But we build those in T-SQL,
Okay.
very similar to the way you build a traditional T-SQL stored procedure.
Okay.
We've got to decorate our stored procedure with a few additional attributes.
Okay.
For example, the stored procedure has to be schema bound.
Okay.
But when we run the stored procedure, when we create the stored procedure,
Okay.
what essentially happens is a DLL
Okay.
is placed on disk.
Okay.
So it's compiled down to native form. You'll notice this if you create one, it takes probably a split second or two longer than
Okay.
a traditional T-SQL
Okay.
stored procedure. And what that allows us to do is get some of the real speed from in memory. So
Okay.
a natively compiled object, in this case a stored procedure,
Mm-hmm.
accessing an in-memory table,
Okay.
we should see a great deal of speed from
Okay.
that.
Interesting you say that. So what level of performance gain can an application actually expect to gain by switching over to in-memory? Like.
Yeah, I guess that depends. It's all down to testing. But it's not uncommon to see like 20-30%.
Well, 20-30% improvement.
I mean, you may, in some scenarios, you may see less than that. In other scenarios, more than that. But I'd expect you to be seeing in a traditional OLTP scenario,
Okay.
at least around the 20% mark.
Okay.
Your mileage might vary though.
20% more or 20 times? Okay.
Yeah.
Okay. Okay. Fine. Interesting. So, what are the things that one should do before migrating the application? What are the challenges does one have in migrating the certain set of tables into in-memory?
Okay. Obviously, it's still a very much kind of a version 1.
Okay. Technology. Yeah.
Yeah, obviously still very much a version 1 technology. But Microsoft's provided some tools
Okay.
to move our traditional disk-based tables
Okay.
to in-memory.
Okay.
So, for example, if you open SQL Server Management Studio, select your disk-based table, right-click on it, get the memory optimization.
Okay. So, typical Microsoft style, we do have tools which can assist us with the recommendations.
Yeah, certainly there's tools there. The memory optimization wizard, that'll tell you any blockers that exist on your table, and it's actually a great way to learn.
Okay.
So I'd advise people who want to learn about in-memory
Okay.
and creating in-memory tables to use that technology and have a real good look at it.
Okay. Okay. Are there any restrictions in terms of certain things are not supported on in memory and so on. Are there any such restrictions?
Yeah, there are quite a few at the minute, Raj.
Okay.
For example, maybe some of the more obvious ones. An identity column has to start at 1 and go up by 1. So if you've got an unusual seed, you won't be able to do that. Sparse columns, XML columns, but some of the bigger blockers that will obviously disappear over time, I feel, are natively compiled objects. They don't support yet the case statements.
Oh really? Okay.
Yeah, case that seems to be a big hurdle. And also correlated subqueries. But I've heard that they probably will be coming along in the next version. I can't guarantee that, but I'd like to think they'll certainly be there in SQL Server V next.
Okay, that's great. So what are the things you would obviously these is things restrictions you would like to see them removed? Is there any other suggestion that you have for the upcoming versions or the things that you'd like to see in memory?
Oh well, I'd like to see full compatibility with
plug in and then it runs fast.
Wouldn't that be great? We could just right click on our on disk tables and say move to in memory. Hopefully that'll be there.
If it is that simple, then you and me won't have too many jobs in the market.
That's right, Raj. That's right. But I do think that in the years to come, 2, 3, 4, 5 years down the track, in memory is going to be like the database technology of choice.
Fine.
People are already starting to talk about legacy for on disk and things like that. So hopefully SQL Server 2020 will all be there.
So your final comments on overall in-memory technology as such, the SQL 2014 and 2016 one. What are your comments looking at this innovation by Microsoft?
Well, I'd say with the innovation, it's something that people should probably keep an eye on, even if they're not going to use it right at the moment. Just because I feel it will be very, very popular in the future. So experiment. If you're not going to use it in production, just take it. See what features you can use, how it varies from on disk. Get to know the concurrency model, because like I say, it's about just more than speed by being in memory, speed by having no locks, no latches, and just investigating the differences. I think people will be surprised and enjoy this great technology.
That's great. That's very nice to know. So we are coming down to the end of the interview, Martin. So thanks a lot. It has been wonderful 20 odd minutes of discussion on in-memory. Thanks a lot for joining DataChannel, and special thanks to you for your time.
Hey Raj, thanks a lot. It's great, and enjoy yourself in memory and at SQL Saturday soon.
Sure. Let's meet in SQL Saturday Sydney too. Thanks a lot.
Cheers.